During this short video clip, we will go and use one of the examples in the book. We will run the example that is in page 200. This example is about neural networks. The aim is to show you how to use neural networks in the context of the book, so you will be able as well to guide yourself in case you want to sort out some certain problem. So the first step is to prepare the data and to decisionalize the series using certain methods. So we have here the steps that we covered during our lecture. What I am going to cover now is this particular example that the author has in page 200. The example is about neural networks and a fitted like forecast. Here is the training period, the validation period. You can find more information about this forecast in the previous pages. And what we are going to do is literally to copy and paste this code that we can find in here, and you will paste the code here in Excel, in R, sorry. So this code, you can find it on the folder R code in Blackboard. And as you can see here, the code starts from here. The book is not giving us the previous code that we need, because I think we have covered this just now many times. You can find as well the data that I use in the folder datasets in Blackboard. So in a nutshell, here you can see how I open in line number 1 the library read Excel to open Excel files. I open as well the library lubridate, although probably that is not needed at the moment, but as we are going to TS the data and use the command window, it might be handy. We download the Excel dataset. Yes, this is the name that I put to the dataset, and you can find it on Blackboard. In Blackboard. So now you have here this name. This name is the same ridership from this dataset that we download from Excel, the column ridership, and it starts in 1991 and finishes in 2004 quarter 3. The frequency is 12 because the data is in months. The validation of number of observations, 36. That is something that we arbitrarily choose. In line number 9 is the number of observations for the training period. That is going to be the length of ridership.ts, which is the column readership, minus nvalid, which is 36. You can check the values here on your right hand side panel. So ntrain is 123. However, since we are calculating some lags in our data set, so I just took the data from 1992. So this forecast actually is taking I am using just the window from 1992 up until 1992, this ntrain, which is 123 minus 12 observations. The same happens here for validation time series. Again, we start here in ntrain plus 1, the next observation, but we need to delete this 12 because we want to analyze 12 lags in our data set. So we are able to run these two lines, and then line 13 we open the library forecast. Now this is central for neural networks. the previous code. I think you already know it because we have gone over this many times. This is only neural networks. This is all what you need to do. We are using here only one variable. Neural networks can use more variables if you want. So if you want to calculate more complex relationships, actually that would be very nice if you want to use neural networks to calculate prices, for instance, in the foreign exchange market or in bond market or in the stock exchange market. So let's open here the library forecast. We need to set the seed because neural networks use random iterations. So when we set a seed, this seed is going to help the computer to find random numbers in order to approximate the best weights for our neural network structure. Please remember that we have a structure, and I explained this during my previous video. So in this line 15, we are using the command netar, which is with the training time series. We are repeating 20 times the iteration, and then we are using here a size of 7 for the hidden layer. We are using 11 previous observations. If you want to get to know what is each thing, so for instance, you can type netar all the time here, and it automatically shows you what is every single letter. So P is the number of seasonal lags used as inputs. So we are using 11 lags as inputs. We could have used actually this with minus 12 probably. I put it because this minus 12 helps when you create yourself your lag variables. But it's not really needed actually. So I'm going to change everything to 1991. Yes, and I'm going to run these lines as the software automatically is using 11 lags, so we are fine. So capital P is the embedding dimension for non-seasonal time series, number of non-seasonal lags used as inputs. We are using just one lag for this one, non-seasonal time series. All right, so we are going to use P equal 1 for that one. So now we control enter, and we use the summary to get the results of this model. You can see here that we have this structure for our neural networks. Actually, we are calculating 99 weights in that structure. If you remember, the weights are on the on each single interaction. Yes, you remember this. We calculated these interactions, and each interaction has a weight. So that is why we have here this. Yes, and it's very difficult to get like a notion of what is minus 1.55. They are just random iterations, like complex calculations by neural networks, doing this complex calculation of these 99 weights of interactions between variables. We are like ensuring that we are like grasping the most complex aspects from the data set. Then after the command summary, we are able to forecast. So we are going to forecast using nvalid, number of periods invalid, and then we find the accuracy. You will be able to calculate this accuracy with any other forecasting technique during our tutorial next week. We are going to cover, or we are going to compare neural networks with other forecasting technique. This is the a graph. This is line 19. I can hit enter here when, for instance, the code is just way too long, just in order just to code, but this is just one single line. Yes. And then with the command axis in line 21, we put these numbers here on the x-axis. With the command lines, we put the fitted values for this calculation of our neural networks. And with the command lines, we add the mean. This mean means that this is the forecast in R. Yes, so this one is the forecast. And finally, we can compare this forecast with the reality. That is why we did a partition for the validation time series. This is the reality. Actually, it's very similar, as you can see. Okay guys, so this is a quick video about how to use the command anytar. It's very simple code, just one variable. As I said before, you can make more complex calculations. You can all the time consult anytar, the help for anytar here, and look at the arguments, and probably go and look at other people's like examples. You can find examples as well in Google, and many other methods in which you will be able to find the results. This is all for the lecture on neural networks, guys, and next week we will not have any lectures. It's week 22, enhancement week, so I will come back to you with more. If you want to meet me, I think the next week will be perfect to meet you all for your presentations. Bye bye.